Hi, my name is Dennis Angel. I am an XRPL developer for XRPL Labs, and today we're going to be talking about peering, or the overlay network. So the agenda for today is peering. So we're going to start with the overlay overview, the peer object and connection lifecycle, connection establishment, handshake and protocol negotiation, peer activation and management, message relaying and squelching, peer disconnection and cleanup, resource management, thread safety, and monitoring and reporting. So the overlay overview. An overlay network is a virtual network built on top of the existing physical or local networks. It connects nodes in a way that is independent of the underlying infrastructure. The overlay enables direct communication between nodes, forming a mesh or graph network that supports the network's goals, such as data sharing, consensus, or distributed computation. So why do we use an overlay network? Overlays provide flexibility, resilience, and scalability. They allow nodes to communicate effectively, even if they are separated by multiple physical networks, and can adapt to changes in network topology or membership. The next section is peer, object, and connection lifecycle. A peer represents another participant in an overlay network. The lifecycle of the peer connection typically includes discovery, which is identifying potential peers to connect with, establishment, initiating and confirming the connection, the activation, making the connection available for communication, maintenance of that connection, which is monitoring and managing the connection's health, and then terminating and closing and cleaning up the connection when it's no longer needed. Why do we manage these life cycles? So managing the life cycle ensures that resources are used efficiently, connections are reliable, and network remains robust and responsive to changes. The next section is the connection establishment. So establishing a connection involves initiating contact between two nodes. This usually requires addressing, so knowing how to reach the node, the IP address, initiation, so sending the request to connect, and then verification, so ensuring that the other node is willing and able to connect. The next section is handshake and protocol negotiation. So once a connection is initiated, a handshake process occurs. This is a mutual exchange of information. The first step is to authenticate, to verify that the identity of the node, to negotiate protocols or agree on the communication rules, such as message formats and supported features. Establishing trust, which ensures both parties are legitimate and compatible. So the next section is on peer activation and management. So after a successful handshake, the connection is activated. The peer is now fully participating member in the overlay, and the management now involves tracking state, so monitoring the peer's status and activity, resource allocation, assigning bandwidth or memory to other resources as needed, and policy enforcement, applying rules for participation such as rate limits or permissions. The next step is message relaying or squelching. So peers then exchange messages to share information and coordinate actions. So relaying is the process of forwarding messages to other peers, while squelching is selectively suppressing redundant or unnecessary messages. So the next step is peer disconnection and cleanup. Connections may be closed due to inactivity, errors, or policy violations. Cleanup involves releasing resources, so freeing memory, bandwidth, and other allocations. Updating state, so removing the peer from the active list, or notifying others, so informing relevant parties of the disconnection. Another step is peer discovery and bootstrapping. So discovery is the process of finding new peers to connect with. Bootstrapping refers to the initial phase when the node joins the network and establishes the first connections. Another process is resource management. Overlay networks must manage finite resources such as bandwidth, memory, and processing power. This involves allocation, distributing resources among peers, limiting, so preventing a single peer from consuming too much, and prioritization, ensuring that critical tasks receive necessary resources. Finally, we have thread safety. In a multi-threaded environment, multiple operations can occur simultaneously, so thread safety ensures that shared data and resources are accessed in a way that prevents conflicts and corruption. So in summary, peering or the overlay functionality is the backbone of distributed networks, enabling nodes to discover, connect, communicate, and cooperate efficiently and securely. Thank you.